All right, this is going to be Calc AB Notes 25. We're going to find volume by using shells. And when I first learned this, I found the name shells to be a little confusing. I think a better name, I don't know if it's really a better name, would be like volume by sort of tree rings, because that's sort of actually what we do. So they're not like a spaghetti type of thing or a pasta type of thing. What they are is cylindrical shells. They're hollowed out. Take a cylinder, cut a cylinder out of it, and you're left with a shell. That's what we mean by the shell. So let's take a look at what we're doing. So this is actually kind of funny because of when I'm currently making this video. It says, hopefully you're very good at finding volumes of revolution by now. I mean, you took the AP exam and they were definitely on it, except if this is 2020 and you're watching this, you took the AP exam and they were definitely not on it because that chapter got knocked out. So this is sort of like a weird historical thing. I don't know. But it turns out, so like the type of volume that we were finding, volumes of revolution, what we would do is we'd find like a big radius and do pi r squared, and then like dx or whatever. And you're basically using cylinders. And you're just adding up lots of cylinders. They look sort of like coins, and you stack a lot of coins, and eventually you get your volume. What we're going to do this time is different, right? So this time, what we're going to do is you kind of have these cylindrical shells. So let me see. So one shell would be, like I was hoping that would be exactly the radius, but it was not. Let's try this one. Oh, that's pretty good. Wait, can I make this make a circle for me? Ah, I can't. What? Can I make it bigger? Good. Oh my gosh. Okay, so we have that cylindrical shell, right? So that's the top down, you're looking at it view. And then over here, we have, so one, it's like the center, 1, 2, the center, 1, 2. So it would be this shell. So this is not as good. And also it's not really a circle, so like I can't really like have it just snap into it, right? So imagine that these are all different heights, right? So what's going to happen is if we had a function like this, what we could do is we could make a rectangle here. And if I take that rectangle and I go around the y-axis, it's going to trace out one of these cylindrical shells. And then I will make another one. And if I rotate that rectangle around the y-axis, it's going to make another cylindrical shell that's of a different height. And if I make enough of them, what I'm going to get is, because I'm doing a finite number, I'm going to get an approximation of the volume. But if I could do an infinite number, I would get the actual volume. That's the whole idea, is that we're going to create a little rectangle, rotate the rectangle around the axis. It creates a cylindrical shell. And then we're going to add up all the cylindrical shells, and that should give us our volume. So what we can do is we can kind of Riemann sum this thing. And what I'm going to do in true Riemann sum fashion, I'm going to take this picture over here, and I'm going to cut it. So I'm just going to slice it, right? Like a toilet paper roll, and you just like cut it straight up and lay it flat. You get a rectangle. So that's what I'm going to do to this thing. So I'm going to cut it, and I'll end up with, how do I draw this? Let me see. Should have thought this through. All right, so this, and then how do I want this to even look? What am I doing? Here we go. I think this will work. Yeah, this is coming together now. I forgot how to draw, literally forgot how to draw a box. That's like my problem. There. Okay, so we sliced it. And now the big long part comes from going around this. Right, so we go around this part right here. Oh man, not perfect, is this. And then the height, so the kind of like width that we're dealing with here, the delta x, this part is represented here. I mean, it's actually just the segment, but it's represented here in that dimension. And then the rest of it I don't know if I don't really want to color this whole thing in. I mean, I do, like secretly, I wish I could just color instead of make all these math videos, but you know the drill. So this, and then raw. This part here is like this face, right? So we cut it up and we get this. Now, what are the dimensions of everything, right? That's like what we need to figure out. So this we said is our delta x. Okay. Now this part right here, up and down here, this part, that's actually just the height of the function. So I'm gonna say that's like f of our r sub I, and then this this part along here is just going to be the circumference of this thing. So we have to decide on r sub I. Once we pick r sub I, you just like use that to figure everything out. So this is going to be 2 pi r, but it's really 2 pi r sub I. So the volume of this little like cylindrical shell that we cut and turned into a rectangular prism, the volume, let's say volume sub I, is going to be, it's 2 pi r sub I times f of r sub I, and then times delta x, right? It's just base times height. The area of the base is delta x times 2 pi r sub I, and then the height is f of r sub I. So this is one cylindrical shell. We want to add all of them up. So we'll go from 1 to n of 2 pi r sub I f of r sub I delta x. And then we want to go to infinity. We want to take an infinite number of them. So we'll let n approach infinity of this 2 pi r sub I f of r sub I delta x. And when we do that and we take that limit, we actually end up with this. This is our formula for volumes by cylindrical shells. So it's 2 pi, comes from the circumference. We're going to go from a to b is just an x value that we start at, and b is an x value that we end at. And then x is kind of the radius, and then f of x is the height, and then dx is kind of like the width of our cylindrical shell. So this is what we're going to end up using. I'm going to come back in the next video and just do a bunch of these. It's like once you start doing them and thinking about them, they're like a little bit easier, I guess, to work out where the formula comes from. Like, is it important where the formula comes from? Like, kind of. Like, this is delta x. If we just went from, say we like started here, this would be A, and let's say that we ended here. So this is now a better picture. This would be B, right? So the radius varies from, it could be anything between A and B. That's where our radius comes from. And then the circumference is 2 pi the radius, but x is just the radius, so 2 pi x. The height is going to be f of x sub I, whatever the radius is at that particular instance. And we go from there. So anyway, I will be back in the next video, and we're going to do a bunch of problems and see if we know what we're doing. So see you there.